Hello friends, this is Vikyan Kundu, and a brief about myself is I have been working with software testing for the last 13 years, and currently I'm working in the New York City area for one of my clients, and I thought of sharing few software testing knowledge with all of you. And so this is a introduction. This is a very basic introduction to software testing, which I'll be explaining today. And towards the end of the slide, I will show the plan for the entire course for software testing, which you can contact me. If you're further interested, you can contact me, and then I'll share the details on how you can access that entire course. So let's get started with a very basic question like what is software testing? So software testing is a way to assess the quality of software and to reduce the risk of software failure in production. So what it means is software testing is basically the explanation comes up like with a question like why we perform the software testing. We perform software testing because we want to minimize the error in the application, and also we want to minimize that the risk of failure when it is put for operation in the actual production environment. So so testing, the way we minimize those failure or the risk in production is software testing. So it's a way to assess the quality of the software, like we measure like how good it is in quality when any software is developed and then it is given to the testing team. And also we want to reduce the risk of failure. Software testing is performed on a business applications, such as like there are several retail applications or banking applications, or there are other applications where direct consumer products are being used by clients. And also like there are multiple environments where we see like software is being used. And software applications implemented for real life operation without testing has a risk of failure, which could result in loss of money, reputation, business, and even human life. So let me explain a little bit about it. I mean, we already discussed about this concept in the first point. So we are trying to explain here like what is the risk, like if you implement a software without testing into the production or in the actual end user operation environment. So this could lead to a loss of money. So why loss of money? Because as you all understand, like when we try to develop a software, we are it's a business, so we are making payment to the development team, and then after the development of the software is completed, we put a lot of money first stage is we put a lot of money in the development because we have to pay the developer to develop the software. Also, we have to pay many other surrounding teams, such as the business owners or the business analyst. So we have to pay them to gather the requirements, and then we have to pay the developer, and after that we have to pay the employees who are deploying the software into the production environment. So there are a lot of money that is involved in actual software deployment to the production. So if suppose like your software is deployed to the production and there is a failure, and we'll have to take that software back from production into the working environment. So that's a loss for the company because we'll have to reinvest the money that we invested in the development environment. Also, we will have to put more money to fix those errors. So there is definitely a lot of money that is going to be counted for loss in this operation. Also, there is a reputation. So when a company puts a software for a production environment, and it has severe failure, and it doesn't work in the production environment, so that causes a bad reputation for the company which is using that software. So a reputation, when the reputation is bad, that directly impacts the business of the company and even human life. So why human life? Of course, so there are several applications which are very critical to human life. For example, the airline software. So if you have a single failure in the airline software, and it could lead to a major accident in the airlines, and it can lead to a loss of human life. So that was just an example. We'll move on to the next slide that says, like, for testing there are few misperceptions and their corrections. So the first misperception is testing only consists of running tests, that is executing the software and checking the results. So often you will see, like, when we work in the real-time project for software testing, we often see this, that when any software is delivered from the development team, um, we we are we are often requested to start testing of that software immediately, because many people think software testing is just executing the test cases and reporting the results. So this is not only the activities for software testing. There are multiple activities that we need to account for in order to complete a end-to-end software testing project. So any software testing project starts with a planning phase, where we analyze the requirement documents, and then we do our test planning. Like, we out of the requirement documents, what should be our test scenarios, what should be our test cases. Also, we need to perform the estimation, we need to perform the test planning, like the date of testing, when is the testing starting, when it is ending, and how many people need to perform the testing. So all these things should happen. Of course, like, all these things whatever I told right now, creation of the test scenario or test case, test strategy, estimation, these things I will explain later in my course. But this was just a brief high level overview to to make you aware of the correction of the statement which we just made. So if anyone says that testing is should only consist of running the test, that's wrong. We need to explain that testing consists of many other activities, starting from the planning phase. Then there should be a reporting phase, there should be a closure phase. There is another misperception saying that testing focuses entirely on the verification of the requirements, user stories, or other specifications. So testing, a major part of testing is verification of the requirements, but testing also performs the validation of the system will meet the user and stakeholder needs when it is put in operational environment, which is a production environment. So along with the requirements, we also check that whenever we are performing testing on the specific software, this software should meet all the stakeholder requirements, which is not even in the requirement document. This concept also I will explain to you when we deep dive into the testing methodologies and procedures. Also, there are different phases of testing. So when we explain all these things, this concept will be explained in better clarity. Next slide, testing, of the objectives of testing. So there are a few pointers here which talks about the objective of testing. First objective is evaluation of documents such as requirements, user stories, and design. So that's the first objective. Like, whenever testing project starts, the testing team is given a requirement document, or if it is an agile environment, then we are given a user stories, and sometimes we are given the technical design document. So we need to review those documents and make sure they are accurate, because the software is going to be developed based on those documents. So that's the first objective of a testing team, to verify that the requirements, user stories, and design are correct. The next objective is to verify all requirements have been fulfilled in the software, in the system under testing. So that is also another thing, that when the software is implemented in the testing environment, we need to make sure that the requirements, or whatever is documented in the requirement document, are properly fulfilled in the system which is given to us for testing. The third is verify if the test object is complete and works as per the expectation of the user and the stakeholders. So this is more of a end-to-end approach concept, where we verify that as a whole, when the software is put in a production environment, that as a whole that software is going to work. For example, we implement I'm taking a retail client example. So, for example, let's consider that retail client has taken a decision to implement a specific credit card, like say Visa credit card, in their production example. So in our testing, we verify that in the system testing, we verify that okay, our application is able to accept the Visa credit card, and also our application is able to complete a transaction when a Visa credit card is used. But as a whole, when we consider this application, so we need to make sure that this credit card payment is authorized by bank, and also when bank is authorizing the transactions, there are several other downstream applications which is able to receive the payment and also process the payment properly. And there are downstream applications, for example, that there will be a sales audit, or there will be a finance applications which should be able to process this sale which is created by this new credit card. So that's how I explain that the new feature which is going to be implemented by the change in software, it should be tested by all applications which is being impacted by the new change. So as a whole, the entire application should work in the production environment. That is also one of the objective of software testing. Fourth, minimize the defects in application. Of course, uh, that is a major goal of testing, that we need to minimize the defects or errors in the applications. Um, the other objective is provide sufficient information to the project stakeholders to help them taking informed decision regarding the level of quality of the system under test. This is more of a objective coming from the communication perspective. Why? The reason being, when we perform a testing on the software, so there are phases of testing, as I mentioned, that I will explain the phases of testing in the later half of this course. But for now, just to explain a little bit, there will be phases. For example, there will be a test execution phase, there will be a reporting phase, and also there will be a test closure phase. So in the test closure phase, we need to send a communication to all the stakeholders of that specific project to let them know that how much testing was conducted, like how many test cases were executed, and how many test cases could not be executed, or how many test cases were passed, failed. All those data we need to send. And also we need to send the data whether there was any defect which was accepted by the project team as a known risk. So we need to send the communication to the stakeholders, making them aware that certain defects were found in the testing process, but those defects were decided to be deferred and it is decided to be deferred, and it will be fixed later phase of that project. So this kind of communication should go to the stakeholders, and so that the stakeholders can decide based on this communication whether they are comfortable to deploy this software into the production environment. The next is reduce the level of risk of inadequate software quality, which we kind of already explained, that we are trying to minimizing the risk of inadequate software quality by performing the software testing. The last is ensure that software meets the contractual and regulatory requirements. Also, we need to make sure that when we are performing any software testing, it should meet some regulatory requirements. So, what are the regulatory requirements? Let's say once again, I'm going back to the credit card example. So, when we accept the credit card from the customer, so we are not supposed to store that entire credit card number in any of our application or any system that is involving the operation of that software. So if we store the customer credit card, that could be a violation of our regulatory requirements. So as part of the testing objective, we also make sure that this kind of regulatory requirements are fulfilled, and the software, when it is put in production environment, the customers are not going to find out that these kind of regulatory requirements are violated by the software. The next slide talks about testing and debugging. Like often you will see these two terms are used as a similar terms, but they are not. So testing and debugging are two different things. So the testing is performed by the testing team, and it shows the failures that are caused by defects in the application under test. So testing always finds the defects. As part of testing team, we are responsible to find the defects, and also we are responsible to report the defects. Whereas debugging is a developmental activity. So the debugging is a responsibility of development team. And when does debugging happens? The debugging happens when a testing team finds out any defect and it is assigned to the development team. So then development team needs to find out the details at what stage the defect is occurring, and then they can perform a step-by-step debugging to find the root cause of the defects. So debugging is used by development team to find the root cause of the defects, and also when they find the root cause, the debugging information helps them to fix the defect also. So what happens after debugging? So after debugging, development team will find the root cause, and also they will fix that defect which testing team is reporting. And after the debugging process, the fixed software will be re-implemented in the testing environment, and then software testing team is responsible to retest that defect and confirm whether the software is working as expected after the defect was fixed. Now, in a typical testing environment, debugging is performed by the development team. However, in few testing methodology, for example, in agile methodology, or there are other testing in, methodology like incremental testing methodology, where testers may be involved in the debugging process. Now, next slide talks about testing at an early stage. So there is always a benefit to start the testing at an early stage. So I will try to explain how it is. Let's say when you perform the testing of an application, there are different stage where you can start the testing of the software. For example, when testing team is given a requirement document, so at that point our validation work starts. So we need to start validating the requirements, whether there is any gap in the requirement. If there is any gap in the requirement document, we need to raise those observations in terms of defects, like when we use a test management tool, which I will explain later in the course. There are several categories of a defect. So defect cannot be only code defect, which is like coming out of code of that software. Defect can be based on any documentation for as such as requirement document. So if we find any gap in the requirement document, then we can create any defect in our defect tracking application, and we can categorize that defect as a requirement defect. So we can start validating the requirement and raise those observations as requirement defects in our defect tracking tool. And in that way we are helping the project team to identify the errors at a very early stage when the development is not even started. And by doing this activity, what we can do is there is a benefit, because the development has not yet started, which means if we identify any error in the requirement or any in the design of the application, so before even software development starts, that those kind of errors can be rectified. So in that case, the let's say we in order to understand this, let's consider that we did not perform the requirement validation and the software development already started. So the software development already started based on some wrong requirements, or there are some requirements which are inadequate. So when software development starts based on those requirements, and the outcome of that development process is a faulty software, and that faulty software gets delivered to a testing environment, and then we find the defects. Well, we find the defects here and the software is not yet in production. So you can argue saying that software is not yet in production, so what is the harm with it? The harm with it is when we we put money for development and the development team is creating a application, so and the outcome is coming to the testing team, and as a testing team we are finding defects in the application. So then that application needs to go back to the development team, and development team will need to fix those problems and then deliver another version of that application to the testing team. So there are multiple iterations which is resulting due to this process because we did not do the requirement validation, or we did not identify those errors in our requirement validation phase, so that the faulty software does not generate out of the development process. Now if we perform a requirement validation and raise those errors out of the requirements, then what is going to happen? Before even the development process started, our requirements are fully validated, and also our requirements are solid and there are no errors in the requirement. And then when development team gets that requirement and then they start building that software and then deliver to the testing team, there is a high chance that we will get that software almost like error free. There could be some errors, there could be developmental errors, there could be configuration error, there could be environmental errors, but the defects which are coming out of the wrong requirements, those defects are prevented even at the testing phase. Like in the testing phase also we don't see those defects. So that's a benefit of performing a testing at the early stage. So we need to always keep it in mind that even though software is not going to the production environment, but if we catch the defects at the early stage of development, there is a direct cost benefit of the project. We don't need to spend money for multiple iterations of development or multiple iterations of testing. So we need to look at from that perspective, like to explain like why testing at early stage is important. So these are the benefits which I just explained in the previous slide, like what are the benefits of early stage of testing. Cost of fixing the defects is much less, and also it helps in efficient development of the software applications. For further reference, you can go to this link and read a detail about it. I will go to the next slide in further explanations. Uh, there are few methodologies which we need to remember correctly. Often you will see, like even in the in a real-time production environment or in the real-time testing project environment, you will see like testing is referred as QA. QA is called quality assurance, but you need to remember that quality assurance, which is QA, and testing, they're not same. They're related or they're similar, but they're not same thing. So I'll try to explain what it is. At a larger concept, quality management has two aspects: quality assurance and quality control. Now, testing activity belongs to quality control. So then what is quality assurance? So quality assurance is a process, like it's a set of activity which are implemented in an organization as process guidelines to ensure that product which is created by adhering to this process meets the quality standard. What it is? Quality assurance, like let's say I'll give an example. We are testing team and we are creating the test scenarios and our test cases. Also we are creating several other documents. For example, like we are creating the test planning document, we're creating the test estimation strategy, or we are creating test reports. So all these things when we are creating, so these documents needs to adhere to some predefined guidelines and process which is defined by the organization that we have worked for. Okay, so there is a team in every organization to make sure that all these outputs, like when we are executing a software testing project, there are several outputs of that testing projects. So all these outputs of the software testing project from different phase of the project are adhering to the process and guidelines which is defined by the organization. So that team which performs these checks and also which enforces this kind of adherence to the guidelines, that team is called the quality assurance team. So these two are related. Why I said related? Because quality assurance team also makes sure that when a testing project is happening, that testing project is adhering to the company's process and also the guidelines. And based on that, when a testing project is adhering to this process and guidelines, which is monitored and enforced by the quality assurance team, then the outcome of this software project is is going to meet the quality standard, is going to meet the standard of the organization, and also it is going to meet the standard of the quality of the product as well. So then testing activity, like whatever testing activity we are performing by adhering to this process, the testing activity belongs to the phase which is called quality control. Moving to the next slide that talks about error, defects and failures. So an error is an activity, or yeah, it is an activity which results in introduction of defects and bugs in software application. So when an error is happening in the development phase, or an error is happening when the software application is being deployed in the testing environment by the person who is deploying the software, or error is happening by the developer who is developing the software. So these errors are being introduced in the application, and these errors are resulting in defects or bugs in the software application. So this is errors. Now outcome of the errors are defects or bugs, like whatever we find, like when the application is in the testing environment, we find the failures and we report those failures in terms of defects or bugs. But those defects or bugs are the results of error which is made by the development or which is made by the deployment team. Now, what is failure? The failure is outcome of a defect. Like when we find a defect, then we report them because those defects are causing a failure in the application which we are testing. And on a broader note, if we do not find those defects and let that application goes to production, so the software is going to fail in the production. That's how the failure is the outcome of defects or bugs. All right. The next slide talks about the defects and the RCA process. So RCA stands for root cause analysis, and RCA for software defects are performed the development team. So what it is means, like when when we find any defect in the software application as a testing team, we report them to the development team. Now the development team fixes performs the debugging step, and then they fix the problems in the software application. So all these things are good, but also the development team will need to track their defects, like what are the defects which are being reported by the testing team, and also based on that they need to perform a regular root cause analysis to make sure when they perform development in the next project, those errors are not repeated. So RCA process is kind of implemented in every project to make sure that whatever errors we are doing, we do not repeat those errors in our next project. Also, we try to find in RCA document that what was the root cause of that error and what is the prevention plan, like what we can do to prevent these kind of errors going forward. So RCA of software defects are performed by the development team. Now, testing team also creates RCA. What is that RCA for? That RCA would be, for example, like there is any defect that was not discovered during the testing phase, and when the software goes to production, that defect is reported from production. So then the business stakeholders request the testing team to create the RCA document to find out like why we were not able to find this defect in our testing phase and what we can do going forward so that these kind of errors are not repeated. The third point, which I already explained in detail, like RCA tries to identify the root cause of the defects and which were discovered in the application, and also tries to come up with a plan to prevent the occurrence of the same or similar root cause in future. Now let's talk about few testing principles. The first is testing shows the presence of defects but not their absence. What it means is testing shows that there are defects in the application, but testing does not guarantee that there is no defect in the application at all. Even if we perform a full phase testing in the application, we do not guarantee like there will be zero defects in the application when it goes to production because of several reasons, not because of that we could not perform a complete testing of the application. Even if we perform a complete testing of the application, there could be still defects found in production because there could be implementation difference. Like ideally the environment where we are performing the testing should match with the production environment, but still sometimes in a real-time environment we see that environment is slightly different in production environment. That could be in terms of the user load, or that could be in terms of the network. So there are multiple different things which can create a difference in the production environment, and that difference in the production environment can lead to some of the defects which were not found in the testing phase. The next point talks about exhaustive testing is impossible. Yes, we can perform testing which is very detailed, but exhaustive testing, which means that, as we already explained, that we cannot guarantee that we have identified all the bugs in the application, or we cannot guarantee that we have we have executed all the scenarios that could be possible with that software. So there are processes which I will be explaining in the later half of this course. So there are process which is implemented by the software testing team, that when we create our test scenarios or when we create our test cases, those test scenarios or test cases are reviewed by the project stakeholders. So, but even then, when a software testing project is performed and it is and after closure it is being implemented in the production, we often find some scenarios that is executed in production and those scenarios were not tested in our test environment because no one thought about that scenario that could happen. So there could be, although it is a rare case, like the percentage of occurrence of this kind of situation is less, but it could happen. So that's why we mentioned that exhaustive testing is impossible. Third point, we have already explained in our early slide that early testing saves time and money. The next one is defects clustered together. What it means is that when we find defects in one area of the application, there is a probability to find more defects in that area of the application. So for example, I will go back to my retail application, which is a small application that I mentioned that let's say our software implementation date, our software should be able to accept a specific credit card, and that credit card is Visa credit card. Now let's say that we find a defect which is the direct violation of the implementation, like the our software is not able to process the Visa credit card. So what happens in that case when we find a defect that the software is not able to process a credit card like a Visa credit card? So obviously the next thing that comes to our mind is a software able to accept any other credit card. So we then test with any other credit card, like say we test with the MasterCard, we test with the American Express card, and there is a there is more possibility to find defects around those scenarios. All right. Even then, we also we then we try to perform testing with several other credit cards or several other payment methods. Like say even cash also we can try to make payment with cash, or we can try to make payment with check, and make sure that all those payment methods are working. But there's a high chance to find defects around that payment method of that application. So that's how it is saying that defects cluster together. When we find defect in one area of the application, there is a high chance that there could be other defects found in that same area of that application. The next thing talks about pesticide paradox. This is a very specific term which I will explain what it is. Um, we create our test case for a software application project, and when we create that test case and we execute those test case, and then we sign off that application and we send it to production. When we get the next project, for the next project also we create new set of test case. Now when we execute that new set of test case, we also need to make sure that a certain percentage of old test case is also executed, and those old features which were implemented in the software applications are still working. Let's take our example, the implementation of the credit cards. So let's say in our project which we are testing, that implements the Visa credit card implementation in the software application. Now that project is completed and we have sent that project to production. After the project is sent to the production, the next phase of the project is coming as we will be accepting the MasterCard in our application. So we will create our test case to make sure that our application is able to process the MasterCard credit card. But also at the same time, we need to make sure that the Visa credit card, which we already implemented to production, that Visa credit card feature is not failing when we are getting the code of MasterCard credit card. So this kind of test is called regression test. That whatever features which we already implemented in previous production deployment are still working good when we receive a new version of the testing, new version of the software application under test. Now this regression testing keeps getting appended after each software feature is going to production. So that's how you will see, like when you enter a real-time testing project, the regression testing, the set of regression testing is pretty large. Like we might have like 3,000, or we might have 5,000 test case in our regression testing. So what pesticide paradox means is we need to regularly revisiting our regression test cases, and also we need to update our regression test cases, so that there are like over the years, when you keep appending the regression test cases, sometimes few test cases are not effective enough to find the defects. Why it is? Let's say we we will take our application example one more time. So let's say when the application was first put in operation, the first feature of the application was the login feature. So we created the test cases of the login feature and we tested it. After that, the application was developed to accept the payment of cash payment. So we created our test case, and also in the regression test case, we added the login functionality. The third phase is after cash. The third phase is our Visa credit card was accepted, and the fourth phase is our MasterCard credit card is being accepted. So when we go to the fourth phase and we are testing that MasterCard is working, of course we are testing that Visa is still accepted. Of course we are testing that cash is still accepted as a payment method. So this regression testing we are performing, but also we are adding our login functionality feature into our regression testing, which is a very stable application which doesn't break. So over several phases of testing, we keep on monitoring and we see that the login functionality is not breaking. So keeping a test case of login functionality in the later phase of testing is not going to give a much benefit to the testing. So that's the concept of pesticide paradox. What it means is we need to keep on revisiting our regression test cases and make sure that regression test cases are still effective to find the defects. If not, if they are not able to find the defects, either we need to discard those test cases, or we need to update those test cases in such a way that they still remain effective to find the defects. The next point is testing is context dependent. Why it is? Because testing, when we perform any testing, that the like that is no predefined phases that you can generalize across all testing applications. So what kind of testing we will be performing, whether we will perform a system testing or regression testing or performance testing. So this concept entirely depends on the software application that we are going to test. That's the context of that software application. So that's why it is told testing is context dependent. So I mentioned about few software testing terms like system testing or regression testing or performance testing. I will be explaining the different types of testing later part of the course. The last point talks about absence of error is fallacy, which we already explained in our previous slide, that we cannot guarantee that there is no error in the software application. So that's a concept, like we cannot say like there is no error in the application. So now we came to the software testing principle. Now the last slide talks about to be continued, like to in the later the session of this course, what are the topics that we are going to cover as part of this course. So for details, please touch base with me. You can leave a comment with your email, or I will provide my email in the comment section of this YouTube video. So you can email me. Also, you can leave your email as comment in this video, and also you can email me with further queries like how to get access to the detail of this course. I will try to reply you, or of course I will reply you whenever I see your emails or request. So the later part of this course will cover the topics like such as like testing types and methodologies, also the concept of SDLC, which is software testing lifecycle, and SDLC, which is software development lifecycle. Then we will talk about requirements, test scenario, test case, traceability matrix with example. We will also talk about test strategy, estimation, and test plan with examples. We will do test execution and reporting. When we do the test execution and reporting, there will be a project that I will execute and show what are the phases and how test execution and reporting is performed. Also, we will show test management tools such as HPALM, and then we will do overview of the test automation using Selenium. So for test automation using Selenium, this course contains only an overview. I am in the process of developing another course with details of test automation using Selenium, which will be posted in my channel pretty soon. So that's all for today. Thank you so much. As I already mentioned, if you have any questions or if you try to reach out to me with further details of this course, please drop a comment in this video. Also, I will drop a comment with my email address in this video itself. Thank you so much.